In this video, we are going to see about the analysis of various trigonometric functions in graphical sense, and also to analyze what basically will be an inverse of a trigonometric function. The first function which we are going to see is my sine function. So basically I will have some equation which will be y equals sine x, where y is nothing but a function of x which will be represented on the y-axis, and x is my variable, that is the independent variable, which will be represented on my x-axis. So if I want to plot the graph of any function, basically I will require its x and the y coordinates. To get the y coordinates, I have to substitute various values of x which the function can take. As you can recollect that we had discussed about the various trigonometric functions, domain and the range. Now domain means what? It is a value which the function can take. So in this particular, if I want to draw this graph, I have to first of all understand what are the values my x can take. So if you can recollect, we had discussed that for sine function, my domain is nothing but the whole real axis. So it can take any value which will be present on my real axis, and accordingly I have to find my y. If you can recollect, the range for sine was between -1 and 1. So my y can have only values between -1 and 1. If you can recollect, in your 10th standard you had done this particular table in which you had taken various values of x, that is my 0, 30, 45, 60 and 90, and then you had written the corresponding values of my sine. So for sine of 0, the value will be 0. Sine of 30, it is half. Sine of 45 will be having the value 1 by root 2. Sine 60 will be root 3 by 2. And sine 90 will be having the value 1. So if I just extend that particular table and write it in terms of my radians, like my pi by 6 is basically 30 degrees, pi by 3 is basically my 60 degrees, and pi by 2 is my 90. So if I make the whole complete cycle, that is from 0 to 2 pi, that is 0 to 360 degrees, then I will be getting these particular set of values. Beyond your 90, that is pi by 2, you can use your allied angles property or allied angles formula to get the values. Now basically what you are going to do is you are going to plot these set of points on the graph to see what the sine function basically looks like. So first coordinate is your 0, 0, so that will be represented over here. Next point, I am getting it as pi by 6. So pi by 6 is basically 30 degrees, and for that I am getting my 0.5. This line over here represents my 0.5 line. This is my 0.87 and this is my 1. So let me consider this point as my pi by. So if I am considering this point as my pi by 6 on the x, and this is my 0.5, though basically that point will lie somewhere over here. Next point is my pi by 3 and 0.87. So pi by 3 can lie somewhere over here, and the corresponding coordinate will be over here. And last one, that is my pi by 2 and 1. So pi by 2 will lie somewhere over here and corresponding 1. So if I just join that, I will get how the sine will look from 0 to pi by 2. So if I continue plotting those points and joining the points, what I will get is something which is looking like this. Now this is basically how a sine function looks like, or it behaves on my graph. If I continue plotting this, I will be continuously getting a graph which will continue on this side also, and also on this side also in the negative half. Just as you saw in sine function how to plot the sine functions using various values of x and the corresponding values of y, I can get my cos function and my tan function. If you observe my cos function, at every pi by 2, 3 pi by 2 and so on, I will be getting the value of cos as 0. At 0 I am getting the maximum value, that is 1. At pi I am getting the minimum value, that is -1. Again at 2 pi I am getting the value 1. So that is why you can see that cos has a periodic function. It is a periodic function with a period of 2 pi. So after every 2 pi interval, my cos function will be repeating. So if you go on plotting this, this will be continuously going on in this fashion only. If you come to the tan function, you will know that at pi by 2 the value is not defined, or basically it goes to infinity. So you can see that at pi by 2 the values are going towards infinity. One thing you can observe over here is my period for tan is basically a pi. Now let us try to understand what basically inverse of any function means. If let us consider this equation, that is y equals f of x. If I substitute some value of x, let us say I substituted x1, I found the corresponding y1 for it. I got the value y1, and now I forgot what was my x1 in the initial case. Now if I try to find some function which will get me back my x1, that means let us say that if I am getting a function which is g, and I substituted inside it y1, and I get my x1 from it, then this g is nothing but inverse of that function. So whenever you are finding an inverse, that is denoted by f inverse. Let us try to understand what is the inverse of a trigonometric function basically means. For that, I will be taking the first inverse of a trigonometric function, which is inverse of a sine function, which is denoted by sine inverse. One thing you have to be cleared about, that sine inverse does not mean 1 upon sine. So please don't get confused with that. It just is a symbol given to it, that is sine inverse. This is one of the symbol used, or the other symbol used is arc sine, which means the same thing, that is inverse of the sine function. Now if in this particular function I am substituting any value, let us say I am substituting 0.5. Now the sine inverse of 0.5 means that I am finding those angles which will give me a 0.5 as the answer when I am taking sine of that angle. So that means if I want to find what is sine inverse of 0.5, I will be finding those angles which will give me a 0.5 as the answer when I am substituting in my sine. So for that, what I can do is I can consider this particular sine wave, which is sine function, which we have represented on the graph. On that, I will be finding where the 0.5 is lying. So on the y-axis, I am finding the 0.5. The line which will be passing through 0.5, and wherever it is intersecting the function are the values of my angles at which I am going to get 0.5. So you are getting pi by 6 and 5 pi by 6 are the angles at which I am getting the value of sine as 0.5. So that means sine inverse of 0.5 will be basically pi by 6 or 5 pi by 6. Now since this is defined as a function, you have to understand that whenever you are having a function, it is to give you only one output. So that is why sine inverse of 0.5, whenever you are finding inverse of a trigonometric function, it is basically defined for a set of values. So for a sine inverse of this, it is going to be defined for the values between minus pi by 2 and pi by 2. So that is why inverse of a sine has the domain of pi by 2. So for a inverse of a sine, my range is defined for minus pi by 2 to pi by 2. Meaning whenever I have a sine inverse of something, I should get, or I should find the angles only between minus pi by 2 to pi by 2. There won't be any other angles which can be considered when you are taking an inverse of that, inverse of any value. So this goes for cos inverse also. For cos inverse also, the values are going to be defined between minus pi by 2 and pi by 2. So the domain for cos and sine is minus pi by 2 to pi by 2. Now let us see what is the domain of this particular function. The domain of the function, since you are going to have the values between 1 and minus 1 only, so the domain defined for inverse of a sine or inverse of a cos, that is cos inverse or sine inverse, the domain will be between minus 1 and 1. So this is basically how an inverse of a trigonometric function is defined. For that you have to understand it is just finding the angles for which that particular value holds. Like if I want to find tan inverse of 1, that means I have to find that angle for which I am getting the value as 1. So tan inverse of 1 will be basically nothing but having the value pi by 4. Next topic is trigonometric equations. In this you will be having equations which will be dealing with trigonometric functions, and then you are finding the values of the unknowns in it. So let us take the first example. I am having sine x equals 0. So this becomes a trigonometric equation. In this I have to find all the values of x for which I am getting a 0. So basically it is finding inverse, but don't get confused, we are not finding the inverse of this, we are finding the solution of this. So we are basically finding the values of x for which I am going to get a 0. So you can recollect that sine becomes 0 at all those values wherein I get the value as n pi. That means x can have the value 0, it can have the value pi, it will have 2 pi and so on, and it will be both positive and negative values. So in general I can write this as n pi, where n is set of integers. So my solution for this equation, that is sin x equals 0, is basically nothing but x equals n pi. Let me go for the next equation, that is cos x equals 0. So if I want to find cos x equals 0, I have to find all those set of values for which my x is going to be 0. So I get cos as 0 at those values wherein I have pi by 2, 3 pi by 2, 5 pi by 2 and so on, both for positive and negative values. So if you generalize this, you get it as x equals 2n plus 1 by 2 into pi. Let me check for what is going to be for my tan x. So tan x equals 0 will have the solution wherein I will be having all those values wherein my sine is going to be basically 0, because my tan x is basically sin x upon cos x. So all those values for which my sin x becomes 0 is basically going to be the same thing for tan. So my x will be n pi. Next trigonometric equation is wherein I am having sin x equals sin alpha. Now one of the solution basically will be my x equals alpha, but I don't want that. I want a generalized version of this. So what I do is I first of all take sin x minus sin alpha equals 0. I apply the formula for sin A minus sin B, which is basically the formula to cos A plus B by 2 into sin A minus B by 2. So if I am having this particular multiple, so it can be either side that cos is 0 or sin is 0. So that means that where it is either cos of x plus alpha by 2 is 0 or sin of x minus alpha by 2 is 0. Because if any one of them is 0, then the equation becomes 0. So let us find what are the values for which my cos is 0. If you can recollect, my cos gets 0 for any particular theta, wherein my theta will be having the values of 2n plus 1 by 2 pi. So basically it means that x plus alpha by 2 will have the values 2n plus 1 by 2 into pi. Let me check for my sine. My sine theta was getting 0 when my theta was having the values of n pi. So basically I will get it as x minus alpha by 2 will be having the values n pi. So if I just multiply this 2 on both sides, I will get x plus alpha by 2 is 2n plus 1 pi, and over here if I multiply 2 on both sides, so I will get x minus alpha is 2n pi. So in this I want to find what is basically x. So my x will be having the values of 2n plus 1 pi minus alpha, or it can have the values x equals 2n pi plus alpha. So you can see that my 2n plus 1 is basically a odd number. That means it can have the values 1, 3, 5 and all that. So for odd numbers I am going to have the relation as x equals some value pi minus alpha. So basically this is x equals for odd number times pi minus alpha, and this becomes a even number times pi plus alpha. If I want to generalize this particular equation, then I will get it as n pi plus alpha into minus 1 raised to n. You can just check it how it happens. Like if I am having a odd number, like odd number I can take as 1. So if I have 1, I will get pi plus alpha into minus 1 raised to 1, which is minus 1. So you are getting a pi minus alpha as the answer. If you are taking an even number, let us say 2, then you will get 2 pi plus alpha, which gives you this particular equation. So it is a generalized version of these two equations which I have written over here. So whenever you have to find what is going to be my sine x equals sine alpha, then the answer can be directly written as this. So let us take an example. If I want to find what is going to be my sine x for 1. Now 1, I know the value occurs at sine of pi by 2. So basically my alpha is now pi by 2. So I will just change that particular value as pi by 2. So you can just apply any values, like you can try it for sine x equals 0.5. So 0.5 value is for pi by 6. So your alpha will change to pi by 6. Okay, so this can be continued with other sets of relations that you can find it for sine cos x equals cos alpha, tan x equals tan alpha, and so on. So those can be done on your own. So you have pretty much idea how to solve a trigonometric equation. So we are concluding with our trigonometric functions today. I hope I would have incorporated some understanding of trigonometric more. I have added some more information in trigonometric function, because the analysis of this trigonometric function is very important in your study of engineering or sciences, and because it's going to be coming in every semester of your engineering and also in your curriculum of 11th and 12th. So it would be better to just practice trigonometric functions, because practice makes you perfect and everyone perfect around you. So the only solution for a trigonometric function is practice. So ending at that note, we will be continuing with many more lectures related to mathematics in the coming future. The next topic which will be dealt in the coming month will be posted in the about page, so please do check it. And also I would like to remind you to go and check the other videos which are related to mechanics and electronics. We'll be dealing with many more topics related to engineering and sciences. So please stay tuned. For that you need to subscribe so that you will get regular updates on our site. Please like the videos and share the videos, and also comment in the comment section if you have any doubts related to the videos, or if you want any other set of video lectures which can be done. So waiting for your comments, and thank you. Keep learning and enjoy learning.